Oh, see something in the chat. Hey, how's it going, sir? How's it going? All right, so looking at polynomial and rational inequalities. All right, so before or up to this point, we looked at linear inequalities, but now we're looking at having like whether it's quadratic or cubic inequalities and also rational inequalities. So when we look at first looking at quadratic, see if I can get this in here. And that's going to set the foundation for how we move with all of them, looking at quadratic inequalities. You know, when you look at our parabola, remember quadratic means we will get a graph of a parabola. You either look like this or look like this. So at these points right here, maybe I use purple, is where our function would be equal to 0. Now, everything above that point, everything will be positive, or there will be increments of being positive, or intervals of being positive, and everything below would be negative. And so we will use test values once we set up our intervals that will represent everything that's above the line and then everything that's below. And you'll see what I mean as we put numbers to it. And then same thing happens here. I would have negative, positive, negative. My intervals being set up by these points. And everything up to this point, from this way up to this point, would be considered negative. Everything in between would be positive because they're above the line. Then everything after it would be negative. And so that's the concept of what we'll be doing as a foundation. We're going to have these intervals set up by where our function is equal to 0. And we're going to figure out where they are positive and where they're negative. And our function, our initial function, will let us know what we're looking for. So let's see, solve. Let's go over here. So here we have 2x squared plus x is greater than 15. First thing you want to do, if it hasn't already been done, is set one side equal to 0. So notice we have this 15 over here. We want to set one side equal to 0. So we'll subtract 15 from both sides. So now we have 2x squared plus x minus 15 is greater than 0. All right. So what this means is you want to know when so it means you want to know when is the equation positive. If you're talking about values that are greater than 0. Just like if you had less than, you will be looking at when was that equation less than 0, which would be negative. So that's why it's important to set one side equal to 0 so you can make a clean comparison to positive versus negative values. All right. So the next step is to solve for when the equation is equal to 0. Remember I told you that these points right here is when your function is equal to 0. So we want to set this equal to 0 and solve it so we can figure out what those points are. All right, so this is factorable, I believe 2x, x. Let's go 3 here, 2 here. So 4, -3, yep. And I put the wrong numbers back there. That should be 3 and 5. So 3 and 5. I don't know why I did 6. So let me check this. 2, that's 6, and that's -5. Yes, that'll work. All right, so if you can factor, you can go ahead and factor. If not, remember you always can use your quadratic formula. Either way, you'll still get the same values for your solutions. All right. So this is when our equation is equal to 0 at these 2 points. And that should be a -3, right? Yep. Now, if I were to put these two numbers on the number line, we can see the intervals that are created here coming from -infinity to -3, -3 to 5/2, 5/2 to positive infinity. Those are the 3 intervals that are created. So we can set up a chart. All right, so our intervals, once we just mentioned, come from -3, no, not -3, -infinity to -3, -3 to 5/2, and 5/2 to positive infinity. Now, don't forget your interval notation. Remember, infinities will always catch your parentheses signs or use a parentheses sign. And then your greater than symbol will always be parentheses as well. Remember, it's greater than or equal to that will get bracket. So, could put parentheses on them all. All right, so I need a test value for each interval. Remember what we mentioned before. When we look at these intervals, everything over here is going to be positive, everything under here is negative, everything over here is positive. So these test values are going to let us know or just solidify how these values respond in these intervals. So we can use -4. Doesn't matter what you choose as long as it's something less than -3. You can choose -100 if you want. It still will give you the same result. Something in between -3 and 5/2. 0 is always an easy value to use. Something greater than 5/2, +4. Once again, you can use anything in those intervals. I could have used 1 for the middle one. I could use 10 for that last one. It will still give you the same result. So now we're going to plug in those test values. I like to use my factored polynomial. So it's 2x minus 5, x plus 3. So plugging in -4. Now, if you want to go ahead and calculate it all the way through, you can. You don't have to. All you need to know is, are we getting a positive result or a negative result? So in the first parentheses, that should be a negative value. Second parentheses, negative. So negative times negative is positive. Next one's x equal to 0. That's 2 times 0 minus 5. 0 plus 3. So that'd be a negative value, positive value, so it's just be negative. So once again, whatever number you get, that's fine. But the fact of the matter is, you want to know, is it positive or is it negative? Because that's what's going to resonate as our final answer. Plugging in +4. Now, as you go higher in math, they will not necessarily always alternate. So that's why you're doing the check, making sure you get the system down so you know what to do and everything like that. Especially when you get into calculus, it will not always alternate, be positive, negative, positive, negative, negative, positive, negative. So you always got to make sure you do it right and make sure you're plugging in correctly. So here we ended up getting positive, negative, positive, which is what we would expect for a parabola. So before we go any further, questions on what we did? All right. So now we're going to go back, make sure we actually answer the question correctly. We want to know, when is 2x squared plus x minus 15 greater than 0? We want to know, when is it positive? So you go back to your intervals and figure out where you got the positive results. And that's this interval and this interval. So your actual answer, I guess I can go down here. Actual answer is going to be negative infinity to -3, 5/2 to infinity. All right, questions before we do another one? All right, so here we have x cubed plus x squared is less than or equal to 4x plus 4. Once again, we want to set one side equal to 0 so we can make that comparison to 0. So we'll minus 4x and minus 4 from both sides. I cancel them all out on the right. That'll get x cubed plus x squared minus 4x minus 4 less than or equal to 0. So this is the function that we'll use. So just like before, solve it, set equal to 0. I don't want to use blue. So since we have 4 more terms, we can use grouping. Don't forget to include that negative with the 4x. First one, we can factor out x. Factor out x squared. So x squared times x plus 1. Next one, factor out negative 4. But I also had to leave x plus 1 in the parentheses. Bring x plus 1 out front. Now you're left with x squared minus 4. Finish off the factoring by factoring the difference of squares. X squared minus 4 is x plus 2, x minus 2. And that'll be x plus 1 equal to 0. X plus 2 equal to 0. And x minus 2 equal to 0. All right, any questions before we look to set up our chart? We have -2, -1, and +2. This time we have 4 intervals. We have this one right here. So we're going from -infinity to -2, -2 to -1, -1 to +2, then +2 to infinity. So our intervals run from -infinity to -2, -2, let me get that closer, to -1, -1 to 2, 2 to infinity. All right, once again, we know our infinity signs. We'll take on parentheses, go back to what our sign was, and we're looking at brackets because of the or equal to sign. So my -2, -1, and +2 should have brackets. That means, don't forget, that means you can include that value, where in parentheses mean you will not include, you will exclude that value. All right, so we need test values now, something less than -2. We can do -3, something in between -1 and -2, -1.5, something in between -2 and 1, -1 and 2, 0, and then something greater than 2, 3. And once again, you do not have to choose those values, but whatever you choose has to be in those intervals. Has to be in those intervals. All right. So we have to plug in each one of those values to figure out what our signs will be in those intervals. So looking at -3, So in that first one, I get a negative value. Second one, get a negative value. Then the third one, I also get a negative value. So that's actually going to be negative for me. Plugging in negative 1.5. So the first one, I get a negative value. Second one, be positive. Third, I get a negative. So that's going to be positive for me. All right, plugging in 0. It's going to be positive, positive, negative. They give me a negative result. Plugging in positive 3. And that'll be a positive result. All right, so questions before we look to finish this problem off? All right, so go back to your original problem. We want to know when is it going to be negative? When is that equation or polynomial? When is it less than or equal to 0? So negative, it's right here, these two intervals. So our answer is negative infinity, negative 3. Oh, negative 2, I'll put a 3. Negative 2 and negative 1 to 2. All right, so that'll be our answer. All right, questions before we look at the next one? Let's see, x plus 3. Let's go less than. Okay, so rational inequalities, the other type of problems you'll see in this section, x plus 3 over x minus 7 is less than 0. So the first thing we want to do is just like before, and the same thing that we established as far as methodology in the last two examples we'll do here. You know, we want one side to be equal to 0. And we already have that, so we don't have to manipulate the problem any with that, with that regard. So now we want to set numerator and denominator. Equal to 0 to establish your intervals. All right, so we're going to set numerator and denominator equal to 0 to establish our intervals, just like we did before, as far as establishing our intervals. So we have x plus 3 equal to 0. That is coming out of the numerator. Then coming out of the denominator, x minus 7 equal to 0. This will be negative 3. This will be positive 7. All right, questions before we go to the next step? All right, so now we want to set up our chart. We have our values for where it's equal to 0. Set your chart. We have interval, test value, and behavior. Got negative infinity to negative 3, negative 3 to 7, and then 7 to positive infinity. Test values, anything less than 3, anything in between negative 3, it's just anything less than negative 3. Then we're looking at negative 3 and 7, something between that, 0, and then something greater than 7, 8. Now remember, when you use parentheses, we are excluding the value. You cannot use 7 or negative 3. We're looking at this value right here. I mean, not value, but inequality. Told us to use parentheses. All right. Now we plug them in. Our equation is x plus 3 over x minus 7. So we're plugging them into that. When x is equal to negative 4. So that's a negative over a negative, which is positive. X is equal to 0. So that's positive over negative, which is negative. Then x equal to 8. 8 plus 3 over 8 minus 7. And that's positive over positive, which is positive. So before we finish it off, make sure we're okay. Found our intervals by plugging in, well, not by plugging in, by setting our numerator and denominator equal to 0. Then within those intervals, we chose values. We plug those in to test how our function would respond in those values or in those intervals. End up getting positive, negative, positive as a result. And we want to know, when is our function less than 0? So when is our function negative? And that's right here. So your answer It's just from -3 to 7. All right, questions? Any questions? All right, let's do one more. All right, so we have x plus 1 over x plus 3 is greater than or equal to 2. So remember, we want to set one side equal to 0. That's not the case. So we want to go ahead and subtract 2 from both sides, and we most definitely want to make sure we're careful here. Because when you are adding fractions, don't forget you have to have common denominators. So 2 has a denominator of 1. That means you need to multiply both top and bottom by x plus 3. All right, so bring them together. Now I can distribute not just 2, but -2 into my parentheses. Make sure you're careful with that negative. Make sure you do distribute it. So there's x minus 1 minus 2x minus 6. All right, combine your like terms. That'll be a negative x minus, yeah, there should be a plus 1. That's x plus 1. So it was x plus 1, I left it off. So, and that's minus 5 over x plus 3. All right, so our new setup will be negative x minus 5 over x plus 3, and we are greater than or equal to 0. All right. Questions before we start to analyze what we have? So just like before, we set each piece equal to 0, numerator and denominator. So it's negative x minus 5 equal to 0. Denominator is x plus 3, so they're equal to 0. So x is going to be equal to negative 5, and then x will be equal to negative 3. Set up your intervals. And then your chart. And your intervals, test values, and then your behavior. Going from negative infinity to -5. -5 to -3. -3 to infinity. We know parentheses will be on our infinity signs. Now here, that tells us to use bracket, but we have to be careful here because bracket means include. All right? But I cannot have 0 in denominator. So the value that gave me 0 in my denominator, which is -3, I cannot use as a part of my solution set. So I will use bracket on the -5, but I'm actually going to still use parentheses on that -3. Because once again, if I put -3 into my function, I get 0 in my denominator, and I cannot have 0 in the denominator. So you're talking about this whole thing cannot be 0. So when that -3 has to be parentheses. All right, so questions before we look to continue. So something less than -5, -6. Number in between -5 and -3, we can do -4. Number greater than -3, I'll go to 0 just because it's always the easy value to plug in. So we're going to use -x minus 5 over x plus 3. Then plug in our 3 test values. That's negative on top, negative on bottom. That's going to be plus, positive. All right, plugging in -4. What did I do? All right, let's see. Did I do something wrong? -3 over these is negative, negative. It's negative, negative. Decrease in between -3, -4. Did I set up my, hold on. Oh, that's why. Okay. I left off a negative. Yep. So always make sure you're careful here. So here, notice we're plugging in negative, -6. So that should be a -6. So I'm plugging in negative and I got a negative right here. So it should be a positive right here. So that's my fault. So that means my first result should be negative, positive over negative. Then here, so it always pays to pay attention to your signs. And then here, that's -4. So it's gonna be a +4. So I give it a negative on top, then negative on bottom. That'll be a positive, negative to a negative. Then plugging in 0. That'll be a negative over a positive, which is negative. All right, questions before we finish it off. All right, so it's negative, positive, negative. We want to know when is this expression, oh, there you go, positive. So the answer is right here. So that's -5 to -3. Bracket on the -5, parentheses on the -3. All right, questions, concerns, comments. All right, so just to do a little mapping of what we have going forward, today is 11/2, 11/4. And 7. Okay, so we did 3, 6, or 7. I think it's 3, 6. 3, 6 a day. 3, 7. Yeah. So all right. So next class we can do 3, 7, and that will be the end of chapter 3. So that means next class, next Monday, we can leave open for you guys to ask whatever questions you want to ask before you have to get into chapter 4. If these questions, overflow the class and we seem like we need another another class to answer questions, then we can do that. But if not, that will be an open class for you to do or ask whatever it is you want to ask. And if we don't have enough questions, then I'll assume everybody's okay. And then I'll roll on to chapter 4. All right. So once again, 11/9, November 9th will be the opportunity for you guys to ask whatever questions. You can even ask questions on next class because 3.7 is not a long chapter at all. So if you have questions, something you want to see done, you run across. So I believe the test review has already been posted. You can always look in there and see if you see some questions you want me to do. And we can do those on the 4th as well. All right. So make sure you take advantage of that. I think I saw this. Go ahead. No idea what this. When you say what is this, you say that you can solve this, is there a problem that you have? Are you about to put it into the chat? Sure, all I see is your sentence. But yep. So, so that's what we'll look to do, and then we'll close out this semester with chapter 4. So chapter 4 is our last section in 161. 162 uses this same book, and starts you off in chapter 5. And also, you should not have to purchase another My Math Lab code or My Math Lab access because you're using the same book. So you should be good to go. But yeah, so we're looking to, I think it's only 4 sections in chapter 4 as well. So yeah. So if you guys are good, I'm good. That's it for today. Like I said, we'll pick up here and do 3, 7 next class and entertain whatever questions you guys may have. So outside of that, you guys have a good day. Make sure you go and vote. exercise your right to vote. And I will see you guys on next class.